Alright, so this is where we ended yesterday. We talked about the different aspects of talked about what the differences were. So, for instance, the sine of theta we said was y over r, which made the cosecant r over y. Okay. Cosine we said was x over r. Secant was r over x. Tangent we said was y over x. And cotangent was x over y. And we liked those two because those used the points. Everything else we had to find what that r value was, what our radius was. So we said when we're finding the reference angle that we should use the inverse tangent of y over x. But we also said that if we do that, we have to drop the negative signs. That's SIGN, those signs. Okay. And that's all well and good through a point. Okay? So, what I would like you to do now is I would like you to find me the sine, the cosine, and the tangent of theta, along with finding me what actually theta is, through when theta goes through the point 8, negative 15. So, going through the point 8, negative 15 puts me down here in quadrant number 4. Okay. My reference angle this would be 8, this would be 15, this would be my reference angle there. 8, 15, is that two parts of Pythagorean triple? So 17, yeah? Yep. So then this is the missing side, there is 17. Okay. So we can find the sine then of theta. Sine is going to be y over r. R just happens to be the hypotenuse of your triangle. So the sine is going to be negative 15 over 17. We can find the cosine of theta. That's going to be 8 over 17. We can find the tangent of theta. That's going to be negative 15 over 8. So we can find all of those just by finding our r value, which was 17. But then we have to use some inverse trick. So my reference angle is going to be the inverse of 15 over 8. I drop the negatives for that. Inverse tangent of 15 divided by 8. In this case, we could have used really any of them. We could use inverse sine, cosine, or tangent because they were all whole numbers, you know. But stick to with what we know. Okay? So I got that my reference angle here is 61.928 degrees. Agree with that? Because we are in quadrant number 4, That means I'm going to go 360 minus that answer, and I'm going to get theta here is 298.072 degrees. Agree? So that's through when it goes through a point. Okay? Now, most of the time, we're going to give it to you like this. Okay? Sometimes we'll give it to you through a point. Sometimes we'll just straight up and we'll tell you that, hey, by the way, the sine of theta is 3/5. Okay? And when the sine of theta is 3/5, we're also saying that the secant is positive. Okay? So we're going to give you some trig function and some other condition. Okay? And so now what we have to do is now we've got to determine where theta is. So if I look at here, I would say that, hey, the sine of theta is positive in quadrant number 1 and quadrant number 2 is where sine is positive. Top half of the unit circle. And then I would look over here and I would say that, hey, secant, well, secant is paired with cosine, right? And so cosine is positive in quadrant number 1 and quadrant number 4. So that tells me that theta is in quadrant 1 because it showed up in both conditions. Okay. So knowing the fact that theta is in quadrant number 1 now, that's going to be theta. Sine from SOHCAHTOA is opposite over hypotenuse. So the opposite side is 3. The hypotenuse is 5. You are supposed to be in here. Yep. Yeah. Okay. Which, that makes a Pythagorean triple, so my missing side is 4. Okay. So the cosine of theta is going to be 4/5. The tangent of theta is going to, whoa, tap the brakes, why did we switch all of a sudden? Random things are happening here, is opposite over hypotenuse, or excuse me, opposite over adjacent, TOA. And theta prime is really just theta, because we're in quadrant number 1. And I can use any of those. Okay? I could use the inverse tangent of 3/4. I could use the inverse sine of 3/5, because that was given to me. I could use the inverse cosine of 4/5. If I type in any of those, I get theta is equal to 36.8699 degrees. Questions on that? What I'd like you to do now is I would like you to try this one. Cosine is negative in 2 and 3. Tangent is positive in 1 and 3. So that tells me that theta is in quadrant number 3. Agree with that? Cosine is adjacent over hypotenuse, right? Do the math or know that it's a Pythagorean triple. Leaves me at 12. Okay. So the sine of theta is going to be 12/13, right? But because it's in quadrant 3, and sine is negative in quadrant 3, it's negative 12/13. Cotangent of theta is adjacent over opposite, so it's 5/12. Cotangent in quadrant 3 is positive, so that's going to stay 5/12. Theta prime now, we can go with inverse tangent, inverse cosine. We can go with any of them, really. I'm going to go with the inverse cosine of 5/13. Okay. Drop the negative sign when we're doing that. When we're finding a reference angle, we drop the negative sign. And I get my angle as 67.380 degrees. But because I'm in quadrant number 3, I have to add 180 to that. So I get theta is 247.380 degrees. Got it? Good job. Yep. Questions on that?
Why are you adding 180 then?
Because I'm in quadrant number 3. Based upon the two conditions that were given to me. Cosine is negative and tangent is positive only in quadrant number 3. So that puts my theta in quadrant number 3. So what I found was a reference angle. So in quadrant 3, to find actual angles, we add the reference angle to 180 degrees.
3 is another quadrant 2 that you have to do that?
Quadrant 2, you subtract from 180. Quadrant 4, you subtract from 360. On last Friday, junior Friday night. Promise. I watched you write it down. We're in quadrant number 3, it's 180 plus the reference